Welcome back, grade 10s. This is the second lesson on empirical formula. I call it remote lesson number 6. We will work through the examples in your textbook on page 281 in this part of the video. So, they give us the following information. Mercury forms a compound with chlorine that contains 73.9% mercury and 26.1% chlorine per mass. Calculate the empirical formula of the compound. So I write down Hg to represent mercury. And below it, I change the percentage by mass to a mass in 100 grams. So if I have 100 grams of this, 73.9 grams would be mercury. And chlorine is the second element. And in 100 grams, 26.1 grams will be the chlorine. In chemistry, the ratios that are the most important would be the mole ratio. So the mole ratio would be determined by taking the mass of the element and dividing it by the molar mass. For mercury, the molar mass is 201. And for chlorine, the molar mass is 35.5. If we take these, the 73.9 and divide it by 201, we get 0.3676. So I'm going to round it off to 8 moles of mercury, to 26.1 divided by 35.5. That gives us a 0.735. To turn the moles into integers, we divide by the smallest of these moles, which is 0.368. Both numbers are divided by 0.368. For the mercury, we get 1. For the chlorine, 0.735 divided by 0.368 would give us a 1.997. 1.997 is very close to 2, so we can round it up to the number 2. So the ratio is 1 atom mercury to 2 atoms chlorine. Therefore, the empirical formula is HgCl2. Today, you have actually learned how they determined the formulas of compounds initially. So it's all analyzed by mass. The elements are determined and analyzed as percentages. The information is obtained, and then they calculate, do the necessary calculations to get to the formulas of the compounds. Very interesting. Right. One last example, a bit more tricky than usual. Sorry. This is our last example on empirical formula. Vinegar, which is used in our homes as a dilute form of acetic acid. A sample of acetic acid has the following percentage composition. Carbon, you have 39.9%, which we turn into mass. Hydrogen, we have 6.7% by mass, so we turn it into grams. and oxygen is 53.4%. And we turn that into mass. The next step is to turn the masses into moles by taking the mole mass and dividing it by the molar mass. Carbon is divided by 12, so 39.9 divided by 12 gives us 3.325 mole. Hydrogen is divided by 1, so it gives us 6.7 mole. And oxygen is divided by 16, so it's 53.4 divided by 16 gives me 3.3375, which I can round to 8 moles. To change these to integers, you divide by the smallest. Right, so divide by the smallest is divide by 3.325. Divide each one by 3.325. Divide each of these moles by 3.325. And you get 1 here. You get very close to 2 here. 6.7 divided by 3.325 is 2.01, which we round to 2. And 3.338 divided by 3.325 gives you 1.004, which we round to 1. So the mole ratio is 1 mole carbon to 2 mole hydrogen to 1 mole oxygen. Acetic acid's empirical formula is CH2O. The actual formula is CH3COOH. So we can reduce that to C2H4O2. That is the actual, the true molecular formula. For acetic acid. I'm ending my lesson on empirical formula here. I hope that my explanations is clear enough. Thank you very much.